Okay, thank you. Good morning, everyone. So my name is Rami. I'm a PhD student at Northumbria University, Newcastle. I'm presenting a knowledge management strategy for urban digital twins, and also on my behalf of my colleagues and supervisors, Omar, Bimal, and Richard. Just a quick background. So recently the concept of digital twin has pervaded the built environment field and in specific the urban management as well. And you're here already because you know about that. So you know also that there is an increasing amount of digital twin projects, demonstrators, pilot projects, case studies with wide range of use cases, this also, all these use cases and demonstrators and pilot projects are increasing the know-how, the knowledge of how digital twins are developed and how we can use them to unlock value. And this knowledge is growing every day. It's increasing and accumulated. So it's crucial if we want to make sure that the use or implementation of digital twins is growing and the whole field is maturing, then we need to capture and share and disseminate this knowledge. So like in the previous presentations, we were talking about data and how to capture the data, and now we're more concerned also with knowledge. That is not just data, the data sets that we use to create the digital twins, but the digital twins themselves as systems and the digital twin projects and use cases. The problem is, however, so far that there seems to be no clear knowledge management strategy to do that. And this limits the ability of the digital twin practitioners to access the DT knowledge or the DT know-how available out there that is implicit in all the executed digital twin projects. So what we're proposing is a codification knowledge management strategy for urban digital twins, and that would enable us to capture and disseminate, reuse and retrieve the digital twin know-how in a codification knowledge management strategy. We use the computers and databases to store and the codified knowledge so that it will be available for everyone else to retrieve and reuse. I can also see how this could be valuable in the future as the users and the digital twin implementation grows, which will help. So the idea is to accommodate this use, the exponential increase in the know-how and the digital twin projects. Otherwise, it will be very difficult for anyone who tries to develop their own digital twin to go out and manually search for all the digital twins that could be of relevance to what they are trying to do. So what we are presenting here now is the system architecture of what we call a knowledge-based system for digital twin design and knowledge transfer. So the model here, or the system architecture, allows different use cases. So first of all, you can, as a user or as a digital twin practitioner, to model whether a previously developed digital twin project or a use case, or what we call a use case scenario, or a new one, design a new one. That is through module number 1, which is called the Digital Twin Design Inference Engine, that allows you to, of course, all is done through the graphical user interface. That's where you start, you perform whatever the use cases you want to do, and then you start modeling the digital twin use case scenario, whether it's a previously executed one or a new one. And the most important point is that you can do that in a standard terminology and modeling language so that it will be able to be codified and then understood by everyone else. This standard language is based on standard terminology and the UML as a modeling language as well, which is all stored in number 2. That's the UML library, including the annotations and also all standard terminology that I will be touching on in a few minutes. The standard modeling and the documentation of digital twin use case scenarios, as we have just said, would enable the searching for and retrieving the relevant digital twin use case scenarios from a pool of the ones that were published in an ontological knowledge base based on logic and similarity. That's number 3. So this ontological knowledge base here, number 3, will include all the published digital twin projects and use cases, and it will allow you, if you're trying to search from within this pool for some relevant use cases or relevant digital twin projects that have been executed previously, then it will allow you to retrieve the relevant ones based on logic and similarity, and I will just explain this in a moment. So speaking about this particular key component of the system, which is the ontological knowledge base, it's made up of 4 layers. So it starts, you can see these green rectangles here, the digital twin system. Like, this is the system itself, the digital twin that has been developed. So in order to classify that, we have developed in a previous publication as well a framework for classifying digital twins. So if I can go in here, so yeah, we developed some standard framework for classifying digital twins. So any digital twin would definitely have a use case that's mostly probably or ideally articulated in terms of a verb plus a noun, like optimized traffic, for instance. And then we've got other dimensions like the application area, the federation, whether it's a digital twin of a subsystem, a system, or a system of systems. The temporality and resolution, like whether it's dynamic, static, and the spatial scale and resolution, the actors and stakeholders involved, the life cycle stage that you're actually targeting by your digital twin. Layering, so if we're speaking about the urban environment, so this includes several layers like the infrastructure assets, the built environment, the socioeconomic environment, and natural environment as well. So we've got all these dimensions that would allow us to classify the digital twin, distinguish one digital twin from another. And if this is a one particular or specific digital twin, then it can be classified using that layer at the top. So these were just examples of application areas, and it goes through all the way for all the 7 dimensions that we have just explained. And then, apart from the specification or the features of the digital twin, we also have what we call digital twin users. So throughout the digital twin project or use case scenario, we've got some standard uses that a digital twin may execute or perform. So we also developed previously a digital twin taxonomy of users. So we've got so many different users. We've got that through a 1-year systematic literature review in order to capture all types of users that digital twins perform, starting from mirroring, analyzing, communicating, and controlling. And it goes down like a hierarchy, as you can see. So mirroring is more concerned with capturing the data or data acquisition. And then when it comes to analysis, this is where you unlock value. This is a key step of digital twin process. So it includes simulations, predictions, computing, data mining, or qualitizing, what we call qualitizing, to verify or improve the asset or the process that you are twinning. And there's the communication. So once the analysis is completed, you can the digital twin can perform different types of communications like visualization, immerse, with this using AR, VR, and all these immersive technologies, and lots of other technology, lots of other communication means as well, including also like engagement, citizen engagement. And at the end, there is also the digital twin use of control, and this would include a human in the loop or not. So whether you inform people to take actions, or digital twins will actuate or activate some actuators to take actions. So this is how you can also identify or determine the different digital twin uses that are being implemented or executed through a particular use case scenario. And then the last layer, when we're talking about how this is actually done, how the use case scenario proceeds. So we used the UML sequence diagrams to model this. So for this particular, for a particular digital twin, again, just a quick recap, it has some features, it performs or executes some digital twin uses, and it also has some digital twin user interactions that is going on throughout the project. This is just a very simple example about how a digital twin may start by capturing the BIM model. And if you can notice that we're trying to use the standard terminology or the standard digital twin uses that we have just explained in the taxonomy. So the words like capture, visualize, monitor, or all these are standard vocabulary, so that we make sure that things could be or can possibly be machine readable and codified. And we've got all the different digital twin subsystems inside like the mirroring system, analyzing, communication, and control, and so on. And these interactions go through between the digital twin subsystems and the digital twin owner, or they could also be different users as well who are interacting with the digital twin system. Okay, sorry. Yep. Yeah, so that's my last slide. So the next step we are trying to do now, is in progress, is we are building a prototype of the knowledge-based system for digital twin design, knowledge, and transfer. We're doing that at our university in Northumbria. The aim is to test how this system will perform in more practical means. We're trying to upload different sample projects of digital twin projects and see how we can codify that, search for it and retrieve the relevant ones based on different search terms and different criteria that we're looking for. And one more step that we're also investigating, I think someone touched on that, like we're not living in a world where everything is open. We've got different owners of different data sets and different digital twins as well. Like if the digital twin is built, someone owns it, and it might be available for some people, it might not be available for others. So we're investigating the idea of having an authorization layer in order to allow some people to search and have access to some digital twin or digital twins, and may not be able to have access to others unless they gain authorization to that. So thank you, and I'm happy to get any more questions about it.